Okay, so let's start. Who's an Android developer in the room? That's a silly question, but that's a real question. You can raise your hand. Okay, good. So a big part of your job is to write code, push it to a device. Then you write instrumented tests, and push it to a device. And you can try to hide, you can try to run. You will always need ADB to make it work, right? And what I propose to do for this conference is to break on through to the other side of ADB and try to see how it's working from inside. So my name is Eyal Lezmy. I'm working at Jenny Mobile on a project that you maybe heard about is Jenny Motion, an Android emulator. You can have my social networks here, and I'm glad and happy to be part of the GD program, Google Developer Experts. That's a Google program to help speakers to speak. Okay, you can have the slides of this presentation right now with this link, bit.ly/adb-nyc. There are almost all the speaker notes, and you have some resources, additional resources from it, so feel free to get it. So the program of today, we'll start with a big picture of ADB, how it works, but the big picture. Then we will tell about a few ADB commands, maybe some that you didn't heard about already, but the idea is also to see what they are doing from inside. Then we'll tell about the internals of ADB, so what are the protocols are used inside, and the fourth part is if you want to start developing on ADB to just grab the source code and understand it a little bit. And on the last part, we will just focus on the Android dev tools and how they are using ADB. Okay, let's start. How ADB works. First, ADB stands for Android Debug Bridge. It's a command line tool, and it helps you to interact with an Android device, right? It's part of the SDK. You can find it on the platform tools folder. And you can have between 1 and 2 versions released by Google. One is the stable. It's always here. And sometimes you have the preview channel for the next version of ADB. Just come in, guys. Take a seat. You have 3 seats there. ADB is a client-server program. And it's composed by 3 parts. You have a client, a server, and a daemon. Let's see what is it for real. So the ADB client, it runs on your computer, and that's actually the binary that is executed, that is launched when you type ADB on your command line. Then you have the daemon. The daemon is a daemon, a background process running on each Android device. And it will execute the ADB orders coming from outside directly on the device. And then you have the server. This server is still running on your machine, and that's the real bridge of ADB. Guys, come in. Don't stand up like this. You have 4 seats there and 2 others, so just take a seat. It will be long. So the ADB server is the real bridge of ADB. It actually links the client and the daemon. And we will see how during this presentation. So first, when you start an ADB command, when you launch an ADB command, the ADB client will be executed. And the first thing he will do is he will ask himself a question. Is there an ADB server running? If it's not running, he will start it himself. I won't go into too much details, but there are interesting things that ADB client is doing to start and to get the information that the ADB server is starting on a good way. But you have that on the speaker note. And when the ADB server is launched, it will bind to a port. It's the 5037. Just one thing, I'm very bad in English in general, but with numbers is worse. So, and there's few numbers in this presentation. So it will bind this port with a TCP server, waiting for other ADB clients to connect and to send information. And we'll see later what. When it finish to bind the server, the ADB server will also scan for Android devices and emulators, physical devices and emulators. So what it will do for the emulators, it will scan on localhost on the port from 5555 to 5681. Never mind. So you have a range of ports, and it will check odd numbered. It's because, and it will look for emulators like this. It's because when you have an emulator, you have the 5555, for example, port that is open for ADB, and the one just before, so 5554, it's for another. It's for another TCP connection. So it will check if there is a device on this port, and then the next one, and the next one, and so on. And then when when he got a device, he will establish a connection to it. And we will see how later. That's the same for the USB interface. For example, on Linux, you will go to the /dev/bus/USB, and it will crawl all the interface waiting for Android devices. So that's the way it knows when you plug in your device, because continuously it will crawl or it will intercept event from USB. Okay, and there is another kind of device, because what we've seen is the Android Studio emulators, XAXM and QEMU. You have the USB devices, but you have another kind of device for ADB, which is called network devices. And for example, so what it means is devices that are on the network that ADB can access, but he won't crawl to find them himself. You will be able to connect it manually. For example, Genymotion devices are network devices. But you can turn many devices, physical devices, to network devices too, and we will see that later. So now we have this kind of big picture, and what we know is that ADB client and ADB server are running on the user's machine, and you have all these ADB daemons that are each one running on a single device. So, and every Android device have an ADB daemon running, or you cannot develop on it, basically. Okay, so let's talk about a few ADB commands. I told you right before that you can turn any physical device to a network device. It can be useful, for example, if you don't want to plug your device to USB. You can do it quite easily. Just plug your device and then type ADB TCP and the port number. Then, when it's done, you just need to connect manually your remote device, your wireless device, using ADB connect and the IP of the device. Right? Is it clear for everybody? Yeah? Okay, so now let's see what this command is doing for real on the device. Oh yeah, one thing. If you want to disable it, just type ADB USB, okay? So what this command is really doing. First, the ADB server will ask the daemon to enable the network connection. And it will do it by sending this message, TCP IP, colon 5555. 5555 is the port you enter on your command. Then, the daemon, when it will receive this message, it will set a system property it's like executing a set prop, and the name of this, I'm very bad, service.adb.tcp.port, okay? And 5555 for the value. So it will set a property. And after doing it, the daemon will close himself. It will call exit, and it will just go away. But the daemon is declared on devices, on Android devices, on initRC as background processes. And so the system will just turn on again ADB. And when it turns on at the startup of the ADB daemon, it will look for a property that is set previously. So it will see that service.adb.tcp.port is set with a port. So at startup, it will open this wireless connection, so this new server waiting for remote ADB servers to connect to it. Okay, so that's how it works. And if we just try to take a step back, that's something you can do manually on a real device. If you have root access, and if you, what you can do is to execute this set of commands. So manually, you go on the command line, type set prop, service ADB, etc. With the port. Then you do stop ADBD and start ADBD. And then it will restart it. And you will have the same effect. And there is something quite interesting, is that instead of writing service.adb, etc., if you write persist.adb, etc., this property will stay, and it will also be used by the daemon. So if you, I don't know, but for example, you have a device farm or something like that with devices that you always want to be on your local network available, and even after reboot, because service dot will not persist after reboot, if you type this command, it will remain after the reboot. So it can be useful sometimes for people. Okay. Another command, ADB devices -L. Who knows that this command exists? A few, yeah. So that can be very interesting sometimes when you are building a internal system for your infrastructure, to know a little bit more on your devices than just having a list of serials. That doesn't mean nothing for real. You can have more information by doing devices-L, and devices will give you, for example, if it's USB, you can have also the model of the device. So this is the Nexus, you know, the Zenfone. This is the Nexus 9. And what you can do, for example, is to know if it's a Genymotion device by on the product you have VBox 86P, things like that. So it gives you more information about the real device behind this blurry serial. Other commands, I will be very quick on that. ADB, you can filter the kind of devices you want to target. So -E will focus on emulators and network devices, and -D on USB devices. Another use case that can be useful for you are the options .h and .p. What they are aimed to do. You have a question?
The previous one, can I filter on other commands than shell?
Yeah. That's any command you have, actually. And you will see how it's made from inside later. So -H and -p allow you to target any ADB server. So you have your own running on localhost, but you can reach another one. Let's see how it can be used. So on my computer, I have my ADB client. Oops, sorry. You lost me, guys.
Actually, I still have you over the stream. You lost you guys.
Yeah. No way.
I guess I gotta stand here.
Please. No. Guys, we will be late. But it will not be my fault, right?
I should have been standing here from the beginning.
Maybe there is this adapter.
Wait a second. Actually, there's a switch in here that.
Oh, yeah, no, yeah.
Just kill it.
No way. Yeah, we're back. I don't touch nothing. Okay, so we're back on our example. So I have my ADB client running on my computer, and I want to reach a remote ADB client. So I will type adb.h, an IP on my local network, for example, and the port by default is the 5037, you remember. So I keep this one, and devices, just to list the devices that are plugged to a remote computer on my local network. So what my ADB client will do is it will just send that to this remote server. And it can be very interesting. Sometimes on your company, you can have, I don't know, a device farm with a few USB devices plugged, with a few emulators running, and you just want to access them remotely, simply, when you have this need. So you can do it. You just need to expose this port on your local network from the device farm server, for example. But you can do it easily. Okay. Yeah, there is another command that I want to tell you about. It's ADB. what is supposed to be displayed? Yeah, the help, the usage, or you can call it any way you want. But there is a small part that I want to show you. This one. Does somebody see something interesting on that? Just to describe you, that's the -p option and his explanation. Okay, -p, just for you, it's an option used by system engineers to do ADB sync. So when they want to kind of flash the modification that they've done on a device, they can use -p to just target a product that they built. Anyway, just to tell you, you won't need that if you are doing Android application development. Okay, let's point to that. Simple product name like sooner or a relative absolute, etc. Who knows what's the sooner is? Oh. There is a Jenny boy to win, guys. Okay, I will show you. This is the sooner. That's the very first Android phone that have never been released. It has never been released. Actually, what happened with this, that the Android OS was in development, and before being on real production, they took some time, so it had been delayed. And they dropped this product in favor of the G1 that we all know, the HTC Dream. That was the very, very first Android phone released. But it was BlackBerry-like, and because the hardware was a little bit outdated when Android OS was ready for production. And it's compared to others, it's crap phone, right? There is a nice story behind the reaction of Andy Rubin after the first iPhone announcement during the Apple keynote. I just wanted to quote it. Holy crap, I guess we're not going to ship that phone. Okay, let's continue. Now let's get real. The internals, how it's working from inside. Let me check the timing. It's finished at 30, right? Yeah? Okay. ADB internals. So we got to our big pictures. The ADB client, the ADB server, the ADB daemon. You know where all is running, right? But you have all these elements, and they need to discuss between each other. So there are protocols for these communications. You have one protocol from a client to the server, and another one from server to a daemon. And there are different protocols. Let's start with the client server. Okay, if I'm a user, I type ADB shell ls. On the ADB client to the server side, here is what will happen. Just to let you know, on this part, I had to be very, very simple on the explanation, just giving you the big picture, that the real precise thing that are happening, but you will have a very good idea of what's happening. But you will miss a few details. So the first thing that the ADB client will tell before anything when it started with the command is to ask the ADB server, what's your protocol version? And it will send this string, this payload. So host colon version, okay? And the ADB server will answer with the answer, of course. And it will answer, okay, 36. 36 is the current released version of the ADB server. And of course, this version will be checked. And then the ADB client will tell what kind of devices he wants to target to the server. So for example, on this example, we don't have any filter, we don't have nothing about that. There is no serial, etc. So it will tell, I want to talk to any kind of device. And the ADB server will answer, okay. And then, finally, we have our real command, the thing that you asked to ADB, that will be sent to the server, shell colon ls, that will ask to the server to execute the service, the shell service with the parameter ls. And then the ADB server will answer with the real output of the LS that have been executed on the daemon side. So you have the full discussion. And the interesting thing to understand that it's that you have three phases all the time when the ADB client is discussing with the server. The first is the startup. So when it asks for the version, etc. Then you have the device selection all the time. And finally, you have the service execution, asking for something to happen for a real command to be executed. And there is something to understand now from something that you encounter quite a lot when you are developing an Android, if you have several ADBs installed, is that sometimes you have an incompatibility between the server running and the ADB that you want to run from the command line. Because, for example, on Genymotion, we are delivering our own ADB because we need it. But we are sometimes, and it's a shame, late with the current release of ADB. So you will have this problem all the time. What you need to do is just kill the server and restart it. It's really easy. But now you understand what's the process behind and why you have this error message. It won't solve your problem, but now you know. Okay, and about the device selection, you've seen that if you target any kind of device, you can this message is send host colon transport -any, and you have several. I won't go into too much detail because it's the boring part of the protocol, all the things that you have. But just need to know that you can, if you target a serial, you will have a transport message that is according to this parameter. And do you remember the -D and the -E? You have dedicated message for that too. Okay, and the ADB service, the most interesting part of the of this process. What it means, an ADB service, it's actually an action that ADB can do for you as a user. And you have two kinds of services. The first is the host services that are executed by the ADB server himself, like devices. When you type ADB devices, it won't ask the daemon for something. And you have the local services that will be executed by the daemon. Here's another list. I'll let you know that just the slide, you can come back on the slide later if you want to understand a little bit more. But this is a list of, you don't have all of them, but you have some of them. So for example, to get the version, the device -L I told you about, etc. Transport also is a host service. So local services, you have shell, of course, it's running on the daemon. Another one that is interesting is frame buffer. This is used for the screen capture, the screenshot of the devices. So you have a dedicated service for that. And another one that I like is the GWP service. This one is used when Android Studio want to debug on a remote thread. If your application is running on debug mode, you can of course debug through it. So the GWP service is used to connect the ADB, the GDB client, the debugger, to the remote process running on the daemon, on the device. Sorry, and the last one is called sync, and it's used for push and pull. I won't go into too much detail in this, but just to let you know, that's it embeds a protocol himself into it. That's quite complicated. No, not complicated, but that's a new level of protocol from inside ADB. I don't want to detail anything, but you can just take a look if you want. You have a few documentation on the source code. Okay, so that was for the client server. Now let's start for the server to daemon. First, what a message that is transmitted from the server to the daemon looks like. It looks like this. You think nothing, right? Okay, let me help you. First, at the beginning, you have a header. The type of this header is an A message. That's a structure we will just see after. And the rest of the message, if the real data the additional data that the message wants to transmit. If you take a look at the structure MSA, I just passed it here, and we will see four parameters, four information that are useful for us to understand how it works. The first is the command. The command is the real verb of the action. The message transports an intention. The command describes this intention. Then you have arg0 and arg1 that are silly name, but actually not. They are generic parameters. They don't have a real meaning like that, but depending on the command, arg0 and arg1, we will have a dedicated signification. We will see some example later. And the last one that is useful for us is the data underscore length information, which describes the length of the data that is following the header. And the other one, you don't care, and me neither. So let's take a new example. We have this ADB command, this ADB command, which is ADB connect, giving an IP and a port. It's when I want, as a user, connect to a remote device, a wireless device, or a local device. So what's happening when I tapping this command? First, the ADB server will send a message to the ADB daemon. I give you a small part, this interesting part of the message, and it describes here the command, the arg1 and the arg2. So the command is cnxn for connection. It's a connect message. I want to connect to you. On the arg1, you have the protocol version, and the arg2, you have the maximum payload size. And you will see this information is interesting. So the maximum payload size is the maximum size of data that a message can be. The ADB daemon will then answer with the same message at the beginning. So the command, the arg0, arg1 and arg0 with the same signification, but with an additional information. Just one thing to precise. So the arg2 here designed the real ADB daemon maximum packet size is it can handle. Okay, so on each side they say, okay, my maximum size is this one, and etc. Okay, so another information that is added on the daemon side is the data, and this data describe actually what is called the device identity string. Do you remember on the device ADB devices -l information, we had this long string with some interesting information that we can parse. So this is the device and the identity string. So when you connect, when an ADB server connects to a daemon, this daemon will answer, okay, I want to connect to you. This is my information, my protocol version, etc. And this is a string that can describe what I'm doing or what I am. Okay, so that was the first pass. So you ADB connect to this device, and it's now connected and it's working. And you will send another command, ADB shell ls. Okay, another one that is pretty simple. What's happening? The ADB server will send this message with the open command, arg1 and arg2 that are very interesting, but I don't have the time to describe what is happening. But I will tell a few words about that. And the data contains the real service to execute with the parameters. This time is shell service with the ls parameter. The ADB daemon answers okay. And let me just show you something. So I told you I will give you just a few words, but what you will see on this conversation is that the arg1 and arg2 here are describing an ID that is coming from the server and the daemon, and each time they will communicate, they will swap this device and daemon IDs, and it allows them to understand what is the real, and to know what is the real conversation, because an ADB server can discuss on several threads with the same ADB daemon, so they need IDs to just target the real conversation and handle the request a good way. Actually, there are multiplexers, so these IDs are used for multiplexing. I hope I will have time just to describe quickly what it implies on the source code. If not, we will skip this part. So after answering OK, ADB daemon will write data to answer the question and the request the server asking. And then the ADB server will answer OK. Each time write is sent, the server will answer, OK, I got your information. So the daemon will send new information, so a new request with write and a new payload of data that will be handled by the server. And then it will close the connection with this other command, close. The ADB server will answer OK again to the write data and close to the close. OK? What you need to understand that is that each time you have a write data, you have an OK message. Until, and the daemon will wait for the OK to send the write. And you will see that will bring an interesting thing to understand is why ADB is now faster. Do you remember the last November, Google team announced that the ADB was now faster. And we will now understand why. So on the message, on the current devices and the current ADB, the maximum payload size is 256 kilobytes. Oops. Yes, so that's now. But before, it was 4 kilobytes. So if we try to figure out what's happening for real and what's the change, we have this example of a payload that requires two write from the daemon, so 2 OKs in return. With the same amount of data, if you want to do this with a 4 kilobytes payload, it will look like this. Yeah. So now they solve it, and it's really faster, right? And that's good. But you understand that the daemon needs also to be updated. For example, that's something we've done on Genymotion because we support from Gingerbread to now Nougat. And of course, these changes have been made only maybe on Lollipop or maybe Marshmallow. But we backported this modification on our ADB daemon. So even on Gingerbread, you will have this fast ADB, which is not the case for manufacturer because they don't really care about that. So if you have Gingerbread devices, they will still continue, physical devices, they will continue to be slow, but we've done the job. And that's one of the reasons I learned some ADB, right, by the way. Okay, just let me check the hour, 20 minutes. Okay, let's be quick. Develop on the ADB project. So now let's get the source code a little bit. You can build your own ADB. The first, on the speaker notes, you have a link to the dependencies requirement that you have to set up. So you have some tools to download, etc. Then you need to fetch the source code, and then you can build it. So this is enough to build your ADB. To get the source code, you need to be on the master branch. Then you repo sync. Then you have a few setup of the environment, and you make -G24 if you have a good computer, and ADB. And this will ask to build the ADB model. So now let's talk a little bit and quickly about the language. Basically, at the beginning, ADB was written in C. And because it had been developed by system engineers. And you know how they love this language. And then they decided to switch to C++. But what they've done really for quite a long time was just changing the extension and also the compiler. But not more than that. They didn't rethink and redesign ADB. Of course, it's a multiplexer. It's hard. But yeah, it implies a few bad things on the source code, and I will try to give you some keys on that. Yeah, but to me, so considering that, it's not written in C++, it's written on one language that you can call on 3 different ways. The first way is C++ instead of C++. You can have also C about ++. And the last one is C++ minus minus. You choose the one you prefer. Yeah, I will skip that part, sorry, just to make sure that we have time. But just something you need to know about the source code of ADB is that it's ubiquitous. Because actually it's cross-platform, Windows, Mac, and Linux. It does many things. It deals with USB on these platforms. It does a lot of things. And also, it's multi-element. So you have the almost same source code for the client, the server, and the daemon. Really, they are sharing a lot of source code. And one thing more that is pretty complex is that ADB is a multiplexer. So it's a complex piece of software. And yeah, and if you see why it's a multiplexer, is because an ADB daemon can receive many requests at the same time. And an ADB server is the node between all that. And it can have many, many ADB clients and many ADB daemons to connect to. So you can imagine how that's a highway. Yes, and there are a few things that are bad in that, because you don't have this, on C, when you develop, you don't have this abstraction that you can have, you can have, but it's not based for that C. On C++, it's possible to have this, an abstraction to do this kind of, ubiquitously, I don't know how to call it, but you can do it very easily, but it's not that thing they've done. So they have these forks of code, and for example, you can check that if you are running on ADB host, it means ADB client or ADB server with that, and it appears 65 times on the source code. You have the same for to check if you are on Windows, and it appears almost 40 times. So it's really hard to follow the ADB source code. Okay, so another thing that is interesting, you can try to debug locally ADB and see what's happening from inside. If you kill the server, export this environment variable, ADB_trace, set it to all or ADB, and then you restart the server. You will have more logs, and it will be very verbose. So, for example, you see that when you type ADB devices, you have host devices that is sent to the server. So you can have more information about the messages that are passed. And the same for the ADB server. You have a file on Linux and on the Mac, and there is another one on Windows, but I let you find it, giving a lot of information about what the server is doing. Okay, so let's take a let's talk a little bit about the dev tools. First, Android Studio. You can get the source code of Android Studio the same way that you can do, because Android Studio is on AOSP. But I want to tell you something. Android Studio does not use ADB. Almost. Actually, Android Studio uses DDMlib. DDMlib is a Java library. It behaves like an ADB client. Do you remember when I showed you, you have the ADB client sending this message through TCP to the server, etc. That's exactly what DDMlib does. It opens a socket, a client socket, and it will just ask questions and communicate with the server. And you can find the source code of DDMlib on many branches, but for Android Studio, you have it on tools/base/DDMlib. And DDMlib does not use ADB. Almost, because it uses ADB only to start the ADB server. DDMlib does not contain the ADB server. The source code of the ADB server will still be ADB that runs, but it will launch the server through the ADB binary. So, but it won't use it as a wrapper to communicate with the server. It will communicate directly with the server. So the model that you have when you use DDMlib is almost the same than before. DDMlib will connect to the this number, the ADB server port. Okay, so what's the difference between DDMlib and the ADB binary? Actually, that's a question that I want to precise. That's what's one of the differences between the DDMlib and the ADB binary. The most important for me is the backward compatibility. The ADB binary supports only the last version. That's the reason why you have this problem of a server that is not compatible with your ADB, etc. That's not the case for DDMlib. DDMlib supports the protocol from version 20, so the ADB version is 10.20. And just for your information, version 20 of the protocol dates from October 2008. So it's pretty large, right? So there are a few things that I want to tell you about DDMlib as your library for your project that make, for me, maybe, I never tried it for real, but that's something I realized by browsing the source code. It's maintained by Google. You have many thousands of daily users, all you in this room, actually. You are using a DDMlib. It's fully open source, Apache license, like almost multiple of on AOSP. And even you still need an ADB binary. That's maybe the good way to go if you are doing Java or Java runtime applications that needs to connect and interact with ADB. So that's maybe a good tool for your project if you need it. That means I'm late. By the way, that's all already available on G-Center, so you can try it today. It's like a keynote announcement, right? Okay. Another thing that is oh, that's our announcement. I just forgot that. We didn't. We also use ADB, and we have a Qt library. Genymotion is mostly developed on Qt. That does what DDMlib does, not as complete because we don't have the same needs. And we want to open source it. We was about to do it. You already have the link for that, but it's still private. But you can try to get it soon. Okay, the Gradle plugin. The Android Gradle plugin. You can still get the source code. I will be quick. Yeah, you can still get the source code, exactly the same thing. And you have the branch, which is Gradle_2.2.0, which is the last release of the Gradle plugin. So you can have the source code of all these tools that you use every day. And you can learn many things. And I learned a few things that I want to share it with you by reading them. So the Android Gradle plugin uses DDMlib, exactly like Android Studio does. And how does the Android Gradle plugin uses DDMlib? Actually, there is a mistake. Oh, let me fix it. That's a silly joke, I'm sorry. So just to make it quick, I don't want to go into too much details also, but the Gradle plugin uses DDMlib. 10 minutes? Oh, great. Oh, we have time. So it uses DDMlib for all the device interaction. Basically, you have that, exactly like Android Studio. That's the main interface to interact with a device for the Gradle plugin, and Android Studio eats DDMlib. So it uses it for install APKs, launch instrumentation tests, get device information, so basically doing ADB shell commands. Okay, and a few classes that you should try to play with on your project. There are private APIs, so be careful. You just need it changed, not it can change. It's changed. I've seen that. The one is device provider, and the other one is connected device. Device provider is used to select the connected device that the Gradle plugin could use, and the connected device helps to interact with a device. So if you want to install, you will use a method in connected device. So you should try to dive in if you have a few needs on your build system, for example. Another thing that is very interesting, and it's also about kind of hacking around the source code. With these two lines, you can, on your build.gradle, you can display all the ADB commands the Gradle plugin is launching. So you import the good class, DDM preferences, and then on this class, you have this static method, set log level, and then what you will get, and then you do your Gradle W, etc. Minus debug, of course, because you need it to be verbose. And what you can get from that is that you can see, for example, the DNDMS executes pm install create, etc. You can also have other information when it will start the instrumentation tests. This is the exact command that is passed. So if you have specific problems, this kind of few line of code could just open your mind about what's happening from inside and know if it's the problem coming from you or the plugin or anything. And it's fully open source. You can contribute to this project. Another interesting thing that I found, and I don't think it's documented, you have these ADB options. So if you open the ADB block, you can open ADB options block, and you have two parameters that you can set. Timeout in milliseconds. So if you have, long delayed ADB connection that fails sometimes your build or your installation or your test, you can change it. And also install options. For example, that's a problem I had on the Genymotion project. We have a few hundred applications that we test every day. And starting Marshmallow, our instrumentation test was not running because of the pop-ups, the permission pop-ups. And our use case, we don't care about these pop-ups. We just want to avoid it. And using the -G helps on that. But it's sometimes hard because on our case, we want to test all the Android versions. So if you put this -G, it will be added to any PM install command that will be run. So for any flavor that we'll use. So using the flavor, we are able to sort it out. And for example, to inject this way, the -G only on the flavor that will contain the Marshmallow and Nougat Android devices. So these install options, you can also inject it directly to a task with this parameter. So I don't know if you already tried this kind of this piece of code, but if you want to just customize your variants before your tests are executed, you can. There is an API, Android dot test variant all, etc. You get the variant, the flavor name, etc. And you can manipulate the tasks that are implied by these variants. And you have these install options too, which is quite useful. It's a little bit hacky, and it's an internal, but it's working well for now for months, so you should try it out. See if you have, of course, these specific needs. Okay, oh, nice. We have something like 6 minutes. I wanted to tell you a little bit about Genymotion Cloud. I cannot tell too much because, that's, does some of you heard about that? Yeah, Genymotion Cloud? No? That's actually Genymotion devices running on the cloud. So you can use it with a browser. So, and what we wanted to do is to make these remote devices running on a data center somewhere in the world being connected to your Android environment. So from this paradigm, so that's the classical Genymotion paradigm, with the cloud, we need to change it to this one. So you have the ADB server and client, and it's going through the cloud. And actually, we learned a lot about ADB for that, and we find a solution that I cannot deliver right now like this, but with all the keys I gave in the conference, you can understand a big part of it. And what I want to do just to finish is to show you just quickly how it works. So this is, yeah, of course. Let's stop it. So I have a device that I can launch. I will be quite quick and not to be boring. Just to let you know, I tried to rehearsal this demo with the two software that are running for the streaming, with the network that is not completely good, and with my computer that is lagging for building Android applications. So maybe the demo will fail because of latency and things like that. But I really wanted to show you because nobody really knows for now what Genymotion Cloud is doing. So yeah, the device is starting right now, and I will go through a command line. Let me clear it. On the command line, I will look for my cloud devices connected. Let me put it larger. Yes, so I have my device, which is on. Oh no. Up, and I will ask for this remote device to just connect to my local ADB with this command line. It takes a few seconds. It takes a few more seconds. Yeah. And if I type ADB devices, I don't see it. Great. Just let me. Oh, yes, you're right. Thank you very much. It does work perfectly. That's a non-fail demo. Okay, let's try to connect. Wow, thank you very much, man. ADB devices, and now you got it. Whoa! Thank you. Okay, so basically what you see now is that if I go to Android Studio, you see you have the logcat that is connected. And actually this remote device is connected to my local environment. I will start to build. I hope it will work because that's the problematic part. Because my device is slow, my computer is a little bit slow, and you have the live stream and things like that, so it will take a few minutes, but it just give me the occasion to show you how you can interact it. So I'm on a browser, this is a Chrome browser, and I can just use this Genymotion device. You have a few widgets that you can use, for example. This is the rotation, things like that. I'm just trying to put some content on this waiting moment, right? So you have the messages and things like that. So you see on this on the cloud the same features that you have on your local Genymotion devices. Where are we? We are still building. Oh, no, nothing happened. If some of you have questions right now, just feel free to ask, one or two. Just time for the demo to start for real. That was so clear. Or maybe nobody understand nothing. Yes.
It seems.
Go ahead.
Oh.
Your turn with the hat.
Oh, okay. A lot of internal users in my company comes to me and says, "Look, can you install the latest APK for me?" Can't they just get their IP then and push the APK to them?
I mean to Genymotion Cloud?
No, actually to their device right away.
I don't understand exactly the use case. What do you say?
You come to me and say, "I want the APK.
Yeah.
Here is my phone."
Yeah.
But instead of giving me the phone, they can just email me their IP address.
Oh, that's a little bit setup because you need ADB.
I need ADB.
Wireless. So you need to configure a little bit on your device. For me, it's more like a developer tool that will. Actually, that's the reason why we created Genymotion Cloud. It's more like, okay, this is this URL. You can use it any way you want, and you can just drag and drop things like on this. But to be frank, the wireless use case of ADB, like you described, for me, it's more like a developer. But if you have people that are hacker-minded on your company, you can do it. It's really easy. Yep.
So, what is the best way to basically man in the middle between the ADB server and ADB daemon to see all of the messages going back and forth, just to inspect them?
I have a sample for that if you want. It's really easy. I have a sample in Qt. I won't release it right now, but I can show you the code if you want. It's a few lines of code actually. So you just need to open a server. Okay, you can do it on a wireless device only, okay? So you have this piece of software that will open a server, a TCP server on any port you want. This server you will do an ADB connect on this port, and then your ADB server will go through this man in the middle, and then it will connect to the remote daemon. Because on your software, you need also to just target to the remote IP of the ADB daemon. Am I clear? Yeah?
Yeah, just basically.
But yeah, that's useful. Okay, so now I have my application that is running on the cloud. And depending on your internet connection, you can have very good interaction with that. I don't think I will do this demo, but for example, we have a quite good connection, and with a better computer, now I have live streams. There are two applications. It's sending many things on the cloud, etc., through the internet connection. But you can even debug your applications. And the idea is not stop using your local devices or USB devices. This is more for collaboration. If you have remote teammates and you want to focus on a specific feature, you want to peer program, you can use if you want, Genymotion Cloud for this kind of use cases. Yes. So I will be short on that. If you have more questions about this product, just let you know that all the thing all the thing I put in this conference is because I learned that for Genymotion Cloud, and you have the keys to understand more now how ADB is working, and implement your man-in-the-middle server if you want. I hope you like it, and if you have questions, feel free to ask.